These are the solutions for the first practice quiz for the 6th quiz in the 3rd trimester of Algebra 2. So you're going to want your little packet of notes here, and preferably a graphing calculator, although you don't really need it. Yeah, I think that will be good. This second page, especially with identities, is going to be very helpful in the process. Okay, problem 1, find the amplitude. And so what's important about this is that you recognize that it is the absolute value of A that we need. So as you look at any particular trig function, let me zoom in just a little bit here, you should know the values of A, B, H, and K. So A is 4, B would be 2, the coefficient of X, and then H is 0 and K is 0. So H and K will be 0 on the particular functions that we study. For the most part, on number 2, K is 3, but the rest of the way, H is 0 and K is 0. So absolute value of A, absolute value of 4. And so the amplitude is essentially the height from the midline. So if you're looking at this down here, this cosine graph, the midline is the x-axis, and that height from the midline is 3. So it's always a positive answer. Find the period. This is 2 pi over the absolute value of b in the given function. So b, the absolute value of b is 2. And so we would cancel those 2's out and leaving us with just pi. So the period is just one cycle of the wave. So if you're looking at this graph down in A, again, one cycle would be from here to here. Number 2, find the minimum, find the maximum. So again, look these formulas up. The minimum is this, K minus the absolute value of A. The maximum is K plus the absolute value of A. So A is 2. So the absolute value of 2 is 2, and then K is 3. So for any particular trig function, you should be able to identify the A value that's multiplied in front, the B value that's the coefficient of X, the H value that's what's added or subtracted inside the parentheses from X, and then the K value is what is added on the end. So if you were staunchly looking to figure out and see the A, the B, the H, and the K, that's how you'd have to write it. Okay, so K is 3 minus the absolute value of A, which would be 2. And then we have 3 plus the absolute value of 2. So this just goes up and down from the midline to give you the minimum and maximum value. So if you're looking at this graph down here again, the K minus A would drop us down here, giving us a minimum of -3, and then the K plus A would bring us up here, giving us a maximum of 3. Pretty simple formulas, but you'll find those in your notes. Okay, 3, 4, 5, and 6. Basically, you want to spot the cosine graphs. Those do not go through 0, 0. And the sine graphs do go through 0, 0. And then maybe look at the amplitude. So on this one, we have a sine graph with an amplitude of 2. So it's going to go through 0, 0 and have an amplitude of 2. And I think this is going to be the graph of C. And then the other sine graph would be D. That goes through 0, 0 and has an amplitude of 3. And the other two are just, you look at the amplitudes. So this is a cosine graph with an amplitude of 3. So that'll be A. And then this is a cosine graph with an amplitude of 2. So the B would go with 6. So you can always discern what coordinate is at x equals 0 by just making sure you're in radians mode on your calculator, and then just, so if I wanted to, let's say I wanted to figure out number 4 here, I do 3 cosine of 2 times 0. So that point would be 0, 3. So that's another thing you can look at is the initial coordinate. And we'll use that idea later on the last problem. Okay, here you want to probably look at your notes with the page on the reciprocal ratios especially. So the idea is to try to convert everything into sine and cosine, or if you see squares, you most likely have a Pythagorean identity. So here's the page I'm talking about. Here are your Pythagorean identities over here. Here's the rule for dividing fractions that we often have. And then reciprocal identities, also powers of those reciprocal identities are allowed. Okay, so cotangent, we can turn that into cosine over sine. And then we can turn cosecant into 1 over sine. And now this is the division of fractions where we want to keep the top the same and then multiply by the reciprocal of the bottom and then simplify that and see if that's an answer. So the signs will drop out and it looks like we are ending up with cosine, and that is an answer. Okay, number 8. So I want to again, excuse me, turn these both into sine and cosine. Ratios, use the reciprocal ratios. So we keep the top the same again, and then multiply by the reciprocal of the bottom. So this is cosine over sine, which that's not a choice, but cotangent is equal to cosine over sine, and that is a choice. Okay, so on number 9, the top is going to be 1. So you want to look on the Pythagorean identities to get these. And then tangent squared plus 1, that is secant squared. So 1 over secant squared, this would be cosine squared. So reciprocal identities with the powers invoked there is what you need to use on that one. Okay, and then 10, you want to again try to turn everything into sine and cosine, and then cancel and reduce and see what you get. So we're going to keep the sine as is. We can put that over 1, and cotangent is cosine over sine. Now I'm going to tell you, you're only going to have to do one simple substitution and you're going to have it. So that proves it, literally. Okay, this is 1 here. 1 plus cotangent squared, that is cosecant squared. And there we go. We've got it. Okay, and so that is true. One simple substitution, nothing really crazy going on with that. So what I showed you on the first page with starting at 0, if you need to get a couple points going, you can with this. This is your delta table, which is going to allow us to determine how many scale marks we skip by. So pi over 2 times b. So b is 2. So it's pi over 4, which is 3 pi over 12. Okay, you need to turn it into pi over 12s to get the scale marks. So we're going to go by 3 scale marks each time. So we need to get the first point. So we're going to have sine of 2 times 0. That's going to be 0. Make sure you're in radians mode if that's what you're going to use. And then, so this will be 3, which is 3 pi over 12. Okay, so make sure you do 2 times 3 pi over 12. And once you get the first couple of points going, that's a 1 right there. you can get the pattern of how this, so it's gonna, so 0 is the midline. So your midline, let me get these values down here, is your K value. When you write all of that down, your K value is the midline. And on all of our graphs, the midline is going to be 0, which is the x-axis. So this helps you to get the fluctuations up and down from that midline. You don't need to fill in with 3 pi over 12, 6 pi over 12, 9 pi. That's what the points literally are, but you don't need to do that. Now, the reason why it's so important to see the midline is because of how the graph opens. So I kind of always just take a highlighter and I'm going to highlight that midline. And then from there, we are going to do this. So we have a 0, 0 point. Then we have 3 pi over 12, but 3 tick marks. And then back down. So this part of the graph is going to look like this. So it's kind of like a parabola opening down, although it's not a parabola. And then we're going to have 9, -1, and then back up to 12, 0. So then we switch over. Once we go below that, you switch over the curving. So that's why it's important to see the midline in making this. Okay, so your midline will be this. You can get a couple of points going by just literally taking your calculator and substituting in. Didn't mean to do that. It points in, make sure you're in radians mode as you do it. And then you can get it started to see how these behave from the midline value. And those are the solutions for the first practice quiz and on quiz 6 in the 3rd trimester.